Hello friends, welcome back. Welcome to session 3 on our course on Introduction to AI and ML. This session is titled Efficacy of Classification Systems. So we are going to be talking about how do you gauge whether your classification system is doing a good job or a not so good job. Okay, that's going to be the topic of today's discussion. Let's get started. Okay, quick recap. In the last session, we talked about the classification problem. Okay, the classification problem was a problem in which you had a data point or an input, and you had to predict the category of that input, based on its observed parameters. Right? So in our specific example that we began with, we were trying to predict the attire, the dress of a person based on their age and gender. So that is what the classification problem was, predicting the category or a class of an input based on its observed parameters. In real life, we are surrounded by classification problems. So if you happen to notice a classification problem around you, feel free to put that down in the comments section of this video. हमने पिछले लेक्चर में क्लासिफिकेशन प्रॉब्लम के बारे में बात की थी. यहाँ पे हम किसी भी डेटा पॉइंट को एक कैटेगरी में असाइन करते हैं, उसको एक अनुमान के तौर पे एक कैटेगरी में असाइन करते हैं, और ये हम करते हैं उसके कुछ गुण या उसके कुछ विशेषताओं के आधार पर. तो ये रहा क्लासिफिकेशन प्रॉब्लम. हमारे आसपास ऐसे कई उदाहरण रहते हैं क्लासिफिकेशन प्रॉब्लम के, और अगर आपको कोई ये ऐसा प्रॉब्लम दिखाई दे तो जरूर कमेंट सेक्शन में लिख दीजिए. Then we talked about what an AI-based classification system looks like. An AI-based classification system essentially has an AI model to which we feed a lot of examples which are known as training data. The AI model then learns on the basis of this training data. Okay, that's called the learning. And then when the AI model has learned, if you give it a priorly unseen test input, a test input that was not seen earlier, it will predict the class or predict the category of that test input. So that is what an AI based classification system looks like. तो AI based classification system ऐसी होती है कि आपके पास एक AI मॉडल रहता है, उसको आप ट्रेन करते हो. ओके, ट्रेन करते हो मतलब काफ़ी सारे उदाहरण देते हो, वो उदाहरणों के बेसिस पे ये मॉडल ट्रेन हो जाता है, और फिर जब आप उसको कुछ नया इनपुट देते हो तो उसका कैटेगरी या उसका क्लास, उसका वर्ग, ये AI मॉडल आपको बता देता है. तो ये होता है AI based classification system. Now it's a fact, and it's pretty obvious that an AI based or any other classification system would not have a 100% accuracy, right? So it will make mistakes. Some inputs it will predict correctly, some inputs it will make mistakes on, right? तो कुछ इनपुट्स पे ये क्लासिफायर सही उत्तर देगा, कुछ इनपुट्स पे ये क्लासिफायर शायद गलती करेगा. सो अगर आपके पास कई सारे AI बेस्ड क्लासिफिकेशन सिस्टम्स है तो हम उनको कैसे जज करेंगे? हाउ डू यू इवैल्यूएट द परफॉर्मेंस ऑफ वन क्लासिफिकेशन सिस्टम वर्सेस अनदर? हाउ डू यू कंपेयर टू क्लासिफिकेशन सिस्टम्स? Clearly, for this purpose, you would need certain metrics based on which, certain numerical metrics based on which you would rank or grade or compare these AI-based classification systems or other classification systems. So that is going to be the topic of today's discussion. We are going to essentially jump into how to compare different classification systems. Metrics to evaluate classification engines. Metrics, okay? So one obvious metric that comes to mind is the accuracy. The accuracy is simply the number of inputs correctly classified by the classifier divided by the total number of inputs. So let's say you trained a classifier, or you had a flowchart based classifier, whichever classifier it was, you gave it a whole bunch of test cases, and out of those test cases it correctly classified some of them and it made mistakes on some others. The ratio of the number of inputs correctly classified to the total number of inputs is known as the accuracy of the classifier, right? तो अगर आपने इस किसी क्लासिफायर को 10 टेस्ट्स दिए और उसमें से 7 पे उसने सही जवाब दिया, तो उस क्लासिफायर की एक्यूरेसी होती है 70%, राइट? इसे कहते हैं एक्यूरेसी ऑफ द क्लासिफिकेशन इंजन. Now, what happens is that in many scenarios, the accuracy is simply not enough. Okay, you need to dive in deeper. You need better understanding of what is actually happening. So, for that reason, we actually need metrics that are a little bit more detailed than simply the accuracy. I call these drill down metrics. Okay. And drill down metrics in classification are defined for each class or each category. Okay, so the accuracy was for the entire classifier, and drill down metrics are for each class or each category. Let's see what these drill down metrics are. Let me go back to the example that we have been talking about, right? So in our example, there were 4 categories, 4 classes or 4 groups based on the attire of the person, right? Now, let us say, for instance, you were not really interested in some of these groups, but you were only interested in one particular group. Okay, so let's say you were only interested in the group of people who wore saris, right? So this was the group that you were interested in. You were particularly not interested in other groups for the moment. So when can this happen? This can, for example, happen when, let's say, if you are a manufacturer and you source your fabric for saris from some different location, right? Or you are an advertiser and you advertise saris a little bit differently. So you are particularly interested in what's happening with the saris, right? These are examples of scenarios where you would be interested in the behavior of the classifier as it pertains to a particular group. So now what is happening in a particular group? Okay, the classifier would again classify some inputs correctly to group C, some inputs it would make a mistake on, okay, or make an error on. So what are the kind of errors the classifier would make as it pertains to group C? 2 types of errors. Error of type 1, right? So error of type 1, people who were predicted to wear a sari by our classifier, but they were not actually wearing a sari. So people whom we predicted would be wearing a sari, but in reality they were not wearing a sari. These are also known as false positives. Positives because in the context of this particular focus group, we said that these cases were positive. We said they were positives, but it turned out to be false. Okay, therefore false positives. The other type of error would be people who were actually wearing a sari, but we predicted that they would be wearing something else, right? So this is the exact counter example of type 1. People who are actually wearing a sari, in real life they were sari, but somehow our classifier said they would be wearing something else. This is what are known as false negatives. Negatives because in the context of our group, our classifier said negative, they don't fall in the group, but we were wrong, hence false, right? So false positives and false negatives are the 2 types of errors that you would see vis-a-vis people in group C, right? और people who were supposed to be in group C. तो यहाँ 2 टाइप के एरर होते हैं. हमें समझिए आप कि आपको सिर्फ एक ग्रुप में रुचि है, ग्रुप सी में आपको सिर्फ रुचि है. तो यहाँ किस प्रकार की गलतियां हमारा क्लासिफायर कर सकता है? एक तो वैसे लोग जो हमारा क्लासिफायर कहता है कि साड़ी पहनेंगे, लेकिन असल में उन्होंने साड़ी नहीं पहनी है, राइट? ये एक टाइप का एरर है, इसे कहते हैं फॉल्स पॉजिटिव्स. और दूसरे टाइप का एरर ये है जहां लोग एक्चुअली साड़ी पहने हुए हैं, लेकिन हमारा क्लासिफायर कहता है कि उन्होंने साड़ी नहीं पहनी है, इसे कहते हैं फॉल्स नेगेटिव्स. दीज आर द टू टाइप ऑफ एरर्स दैट वुड बी पर्टेनिंग टू दिस पर्टिकुलर ग्रुप, राइट? ये 2 टाइप के एरर्स है. ओके, तो हम ये पॉइंट थोड़ा सा मैं एलैबोरेट करने के लिए मैं अपना फ्लो चार्ट आपको दिखाऊंगा. ओके, Let me move my camera somewhere else. Got it. Just in order to illustrate, I mean, these kind of errors would happen in any classifier, right? False positives, false negatives. But just to sort of, just to give you a better explanation of what is going on, what these errors really are, let's look at our flowchart implementation, right? In our flowchart implementation that we did, we said that if the gender was female, and if it was an older person, then we would predict that the person would be wearing a sari, right? This was what our flowchart implementation was. Now here is an example of error of type 1, false positives. Okay, this is clearly an older person and it's a female, but she's not wearing a sari. So this is an example of a false positive, right? Here is an example of false negative. This person is a person who is who's probably young and is a female, but our classifier would not have guessed that she would be wearing a sari. We would not have put her in this group. We would have put her in another group. However, she is indeed wearing a sari, right? So this is an example of false negatives, right? तो हमारे फ्लोचार्ट के बारे में मैं बता रहा था, ये फॉल्स पॉजिटिव और फॉल्स नेगेटिव के उदाहरण है. यहाँ पे एक बुजुर्ग महिला है. हमारा फ्लोचार्ट ये कहता है कि इस व्यक्ति ने साड़ी पहनी होनी चाहिए थी, राइट, लेकिन उसने साड़ी नहीं पहनी है. ये है एग्जाम्पल ऑफ फॉल्स पॉजिटिव. और ये दूसरी महिला है जो यंग है. हमारे क्लासिफायर के हिसाब से उसने कुछ और पहना हुआ था, लेकिन असल में तो उन्होंने साड़ी पहनी है. तो ये है फॉल्स नेगेटिव्स का उदाहरण, राइट. सो दीज आर एग्जांपल्स ऑफ फॉल्स पॉजिटिव्स एंड फॉल्स नेगेटिव्स. आई एम गिविंग दिस एग्जांपल टू सॉर्ट ऑफ so that they stick in your mind. One way to make them stick in your mind even further is to try and guess who these two people are, who these two individuals are. And if you can figure out who these two individuals are in this photograph, I have anonymized them, but if you can figure that out, please do put that in the comments, right? Okay. So now let's jump into the definitions. Now that you have understood the broad the broad picture, let's jump down to the definitions. We have two types of metrics, right, for the two types of errors. Two types of metrics for each class or each group. In this particular case, we are talking about the class sari. Precision, okay, precision. Precision is defined as the ratio of inputs correctly guessed as group C divided by inputs correctly guessed plus guessed as group C but not wearing a sari. Okay, so these are actually false positives. So the precision has something in the numerator which is the right score for our classifier as far as saris are concerned, and in the denominator it is numerator plus something else. The plus something else is the count of people who we predicted would be in group C but were not actually wearing a sari. The other metric is called recall. Okay, recall. Here the numerator is the same, that is our correct count, inputs correctly guessed as group C, and in the denominator it's inputs correctly guessed as group C sari plus the count of those people who we did not guess would be wearing a sari, although in reality they actually were. Okay, so the false negatives that we are talking about. So this is recall, this is precision, right? And you want to aim for a high precision, you want to aim for a high recall. The way to increase precision is to sort of reduce the denominator, and the way to reduce the denominator would be to reduce this quantity. Similarly, to the way to increase your recall would be to reduce this quantity. Okay, so these are the definitions of precision and recall. तो ये हमने कुछ फॉर्मूला दिए हुए हैं. प्रिसीजन और रिकॉल ये दो चीज़ें रहती है, और ये दोनों चीज़ें आपको इंक्रीज करनी है. जितनी ज़्यादा हो उतना अच्छा रहेगा. लेट्स टेक अ न्यूमेरिकल एग्जांपल. ओके, Now I know you can plug in numbers into a formula and get answers, but there is a reason why I'm giving this numerical example. So let's say the number of people who are actually wearing a sari is 34. Okay. Number of people who are classifier predicted would be in group C is 69, and the number of people who are wearing a sari and who are correctly predicted to be wearing a sari is 25. So precision would be 25 divided by 69. Okay, and recall would be 25 divided by 34. Okay, so look at these numbers. So the precision here is approximately I guess 36%. Okay, and the recall over here is, let's say, approximately 74%. Right? Okay, so these are the quantities. The numerator is same in both cases, and the denominator changes on the parameter you are evaluating. Okay. Actually, you know, a lot of people will tell you that there is an inverse relationship between precision and recall. As precision goes up, recall goes down, you know, some sort of a mathematical relationship. The fact is that there is no mathematical relationship or a theoretical relationship that says that precision is inversely related to recall, or recall is inversely related to precision. There is no such mathematical relationship. Okay. However, in practice, when you are working on your algorithms, when you are working on your models, if you try to increase the recall, the precision seems to go down. And if you try to increase the precision, the recall seems to go down. So this is an observation that you often see when you are tuning your algorithms or when you are working on your AI programs. Okay. So I was sort of trying to think of an analogy where, you know, I wanted to explain why is it that there is no theoretical inverse relationship, but at the same time this observation is there that if you try to push up one, the other one goes down. I sort of thought of an example from cricket. Okay, cricket, a game that many of you are familiar with, right? So in cricket, you will often find commentators say that you know, two things about batsmen: how much time the batsman stays at the crease, and how many runs the batsman scores, right? And a lot of time the commentators say that if you want to spend more time at the crease, you end up scoring fewer runs because you're playing safe. On the other hand, if you try to score runs, you are not likely to end up spending too much time at the crease. So people who try to score runs end up spending less time at the crease, and vice versa, right? So this is exactly like that. Now in cricket, although commentators say that, there is no theoretical formula that says that, you know, if you score more runs, you end up spending less time at the crease. I mean, there are numerous examples of good batsmen who score runs and at the same time spend a lot of time at the crease. Right? There are numerous examples of good batsmen. So that is the analogy I want to give. Although it's an observation that increasing one reduces the other, there is no theoretical formula per se. There are good batsmen who score runs and who spend more time at the crease. Similarly, there are good classification algorithms that have a high precision and also have a high recall. Okay, that is the analogy I want you guys to keep in mind. ओके हिंदी में बताता हूँ. ये है फॉर्मूलाज, हमने ये नंबर्स डाल दिए हैं और प्रिसीजन और रिकॉल के परसेंटेजेस देख रहे हैं हम. आपको कई लोग कहेंगे कि आप अगर प्रिसीजन बढ़ता है तो रिकॉल कम हो जाता है वगैरह वगैरह. ये सच है कि अगर आप काम करते हो तो ये आपको दिखाई देगा कि शायद आप प्रिसीजन बढ़ाने की कोशिश में रिकॉल कम हो जाता है, या रिकॉल बढ़ाने की कोशिश में प्रिसीजन कम हो जाता है. ये आप देख सकते हैं, शायद हो सकता है. लेकिन क्रिकेट का अगर हम उदाहरण लें, ये ऐसे ही है कि कमेंटेटर कहते रहते हैं कि अगर आपको क्रीज पे वक्त गुजारना है तो रन रेट थोड़ा स्लो हो जाता है, अगर आप रन को स्कोर करने की कोशिश करेंगे तो आप क्रीज पे टिके नहीं रहेंगे वगैरह वगैरह. लेकिन ये सच है कि ऐसे कई बैट्समैन हैं जो रन्स भी बनाते हैं और क्रीज पे टिके भी रहते हैं. वैसे ही आपको भी ऐसी एल्गोरिथम्स, ऐसी क्लासिफिकेशन इंजिन्स देखनी है जहां प्रिसीजन भी बढ़िया हो और जिनका रिकॉल भी बढ़िया हो. ठीक है, तो ये पॉइंट मुझे करना था ये इस न्यूमेरिकल एग्जाम्पल के द्वारा. दैट्स द पॉइंट आई वांटेड टू मेक. लेट्स मूव ऑन. ओके, Another way of defining precision is in terms of true positives, false positives, etc. Precision is true positives divided by true positives plus false positives, and recall is true positives divided by true positives plus false negatives, right? And why is that observation that people make? It's the reason is that, you know, in any algorithm or when you're developing your code, if you try to reduce false negatives, what you're effectively doing is trying to push more and more inputs into that class, and what that ends up doing is increases your false positives and vice versa. But like I said, as an AI engineer, it's your challenge to develop algorithms that have high precision and high recall. Okay, let's move on. Okay, good point, important point I want to make here. Precision and recall are particularly useful when the categories are unbalanced, that is not roughly equally populated. When the categories are not are unequally populated by far, precision and recall are particularly useful measures. So let me explain what this means. Okay, let's go back to our example. That example has been helping us a lot. The example where we created categories of people's attires and classified people into those categories based on their attires, right? Now suppose I had a group 5 where, you know, it was the category of all people who were dressed like clowns. Okay, clowns. So if, for example, you had that category and your classifier did not do a good job with clowns in terms of classifying, in terms of guessing that some people were clowns, let's say it did a terrible job, it got everything wrong, it would still not have a big impact on the overall accuracy of the classifier, simply because there are too few clowns on a street, right? So you would typically not find people dressed in clownish attires walking around, maybe 2, 3, I don't know how many you would find. I don't see too many around, but you know, they are very few in comparison with people dressed in the other attires that we talked about. So even if you got all of them wrong, it would not make a big impact mathematically to the overall accuracy of the classifier. Therefore, if you were particularly interested in clowns, you would need to look at the precision and recall of the clown category, right? That is when precision and recall are particularly useful. So मैं ये बता रहा था कि अगर हमने जो एग्जाम्पल लिया था उसमें हमने और एक कैटेगरी अगर बनाते थे जो जोकर जैसे कपड़े पहन के लोग घूमते हैं, राइट? तो चाहे आपके क्लासिफायर ने ऐसे लोगों को पूरा की पूरी सभी लोगों पे गलती कर दी, सभी जोकर्स पे गलती कर दी, फिर भी ओवरऑल एक्यूरेसी में ज़्यादा उसका इम्पैक्ट नहीं होता, क्योंकि जोकर जैसे कपड़े पहन के घूमने वाले लोग कम होते हैं, राइट? सो इन टर्म्स ऑफ नंबर्स it would not make a big change to the accuracy of the overall classifier. तो अगर आपको specifically jokers पे ध्यान देना हो तो वो joker कैटेगरी की precision और recall काम में आपको आएगी, क्योंकि overall accuracy में ये चीज़ capture नहीं होगी कि आपका classifier jokers पे बहुत ही खराब काम कर रहा है. Okay, so this is one important reason to use precision and recalls when the categories are unbalanced, for example when jokers are just far too few in number compared to other people. Okay, go back to our old block diagram of an AI based classification system. ये है हमारा AI based classification system जहाँ एक मॉडल होता है, ट्रेनिंग एग्जाम्पल्स होती है, और फिर एक टेस्ट इनपुट को ये एआई मॉडल क्लासिफाई करता है. ये है हमारा एआई बेस्ड क्लासिफायर. तो अभी अगर हमको इस क्लासिफायर की एक्यूरेसी बढ़ानी हो, किसी क्लास का प्रिसीजन या रिकॉल बढ़ाना हो, तो हम क्या कर सकते हैं? दो ही चीज़ें कर सकते हैं, राइट? एक तो उसका एआई मॉडल बेहतर बना सकते हैं, राइट? ये एआई मॉडल हम बेहतर बना सकते हैं, या फिर ट्रेनिंग डेटा बढ़िया ले सकते हैं, ऑनेस्ट ट्रेनिंग डेटा ले सकते हैं, बढ़िया ट्रेनिंग डेटा ले सकते हैं. और यही दो चीज़ें हम कर सकते हैं अगर हमको एक बढ़िया क्लासिफायर लिखना हो तो. सो द टू वेज टू improve the effectiveness of the classifier is to either focus on picking or developing the right AI model, or the focusing on getting good training data, ideally doing both. I mean, not one, it's not one or the other. You have to do both of these things to build a good classifier. So this is what you can do, and going forward these are going to be the things that we are going to focus on. Summary. Okay, in this lecture we talked about measuring the effectiveness of a classifier. In particular, we talked about terms like accuracy, precision, and recall. Okay, if you are an AI engineer, if you are developing algorithms, please focus on all of these. अगर आप AI algorithms develop कर रहे हो तो इन तीनों पे आपको ध्यान देना ज़रूरी है. And if you are just a lay person who's listening to these lectures, just keep in mind that there is more than just the overall accuracy. You need to look under the hood. If you like this lecture, if you like my teaching style, please do subscribe, please do put your comments. Like I said in the past, love to hear from you, but this is all I have for today, and let's close here. Thank you. Goodbye.